Universities face an immediate mandate to integrate AI into modern pedagogy. Administrators and students expect classrooms to leverage this massive flood of new processing power. But this mandate collides with a severe academic risk. Large language models frequently invent facts out of thin air, an error known as hallucination. In an academic context, hallucination is toxic. If a generated slide presents fabricated dates or non-existent theories, it destroys pedagogical trust and ruins student reliance on the material. Because of this, typing open-ended prompts into standard models is incompatible with rigorous academics. The output is simply too unpredictable. Relying on unverified outputs directly threatens the credibility of the educator and the research institution. We must harness the processing power of AI without exposing classrooms to fabricated noise. This split screen shows the architectural solution, the Retrieval Augmented Generation Framework. Left, a standard AI pulls from a chaotic web cloud, creating high risk for hallucination. Right, the RAG framework strictly tethers to a locked box of uploaded documents, ignoring the open web. Educators can deploy tools built on this framework, like NotebookLM, to create a strict closed-loop environment for their course materials. By forcing the AI to reference only what you provide, this framework ensures that every generated claim is anchored back to a specific, professor-approved source. Think of NotebookLM as the practical user interface for deploying this closed-loop architecture in your daily workflow. This diagram illustrates the system's source vault. On a standard free tier, you are given a strict limit of 50 empty slots to hold your curated source materials. You populate these slots with chosen academic materials, web links, digital textbooks, text files, and PDFs. Once uploaded, the AI is functionally restricted. When you ask it a question, it can generate answers derived exclusively from these populated slots. This hard boundary structurally restricts the model's search space. It prevents the system from reaching for outside, unverified opinions to fill in gaps in its training data. Occasionally, you will encounter technical glitches during ingestion, particularly when a source contains image files that the vault fails to read. The bypass for this is straightforward. Upload that unreadable image into Gemini, prompt it to extract the text, and manually paste that extracted text back into your NotebookLM vault. By strictly curating this ingestible corpus and managing the inputs, you are no longer a passive prompter. You act as an active systems architect, controlling the exact boundaries of your course. Synthesizing up to 50 dense academic texts simultaneously creates a new problem: information overload. The AI's responses can easily become too detailed for a general class introduction. To counter this, we use the filtering hack. This diagram shows how we force extreme conciseness by isolating outputs. Prompt the AI to generate a simplified concept explanation, then copy that exact concise output, clear your vault, and upload it as a single new source. This deliberate isolation technique guarantees that your subsequent lecture aids are highly focused and digestible for students, while maintaining perfect factual grounding from the original corpus. We can map out an exact sequence of operations to synthesize a comprehensive teaching case from scattered, real-world data points. Start by uploading multiple, disparate industry news clippings and market reports about a specific challenge into your established vault. Instead of asking the AI to simply summarize the news, you use a precise prompt architecture to weave these clippings into a unified narrative document. This visual layout demonstrates the required structural elements. You must prompt the AI to explicitly generate blocks for the case's context and background based entirely on the vault's data. Next, mandate the creation of a distinct protagonist who is facing a clear, measurable decision dilemma. Finally, direct the AI to generate various decision alternatives. This creates the analytical tension required for debate in the classroom. This structured prompting transforms what were once disconnected raw news articles into a formally recognized pedagogical asset. Standardizing case structures through this exact prompt architecture allows for the rapid transformation of raw data into classroom-ready material, condensing days of manual synthesis into a single afternoon. Once the primary teaching case is built, you enter the derivative loop to mass-produce supplementary academic aids. The mandatory first step is to copy your finalized teaching case and upload it back into a fresh system as a new, standalone source. Because the AI is now restricted entirely to your completed case, you can prompt it to generate perfectly aligned teaching notes and discussion rubrics. From that single source, you can instantly generate derivative outputs, including accurate study flashcards and multiple choice quizzes. You can also pivot these resources into active classroom engagement techniques, using external tools like Gemini to introduce gamification. This diagram illustrates a guess the theory decision tree game format. The AI acts as a host, asking students yes or no questions to help them hone in on a specific academic concept. Adapting this interactive exercise into a live classroom setting forces students to actively deduce answers, boosting their engagement with unfamiliar concepts. There is also a multimedia hack for securing ready-made lecture scripts. If you upload an explainer video directly into NotebookLM, the system automatically extracts its transcript, giving faculty an immediate, highly accurate script to study or adapt. By treating these AI tools as an interconnected assembly line, you can generate an entire suite of perfectly aligned materials, from scripts to quizzes, starting from one single verified document. Looking beyond text, we can tap into creative capabilities to engage students with complex material, such as generating a thematic song case. The exact pipeline involves downloading a visual comic strip generated from NotebookLM and feeding that file directly into Gemini's music tool. You instruct the AI to generate a thought-provoking, rhyming song that summarizes the specific dilemma of your teaching case. Crucially, this workflow possesses deep multilingual capabilities. All generated artifacts, from slide decks to complex mind maps and fully produced songs, can be translated into vernacular languages, such as Telugu. Generating these localized visual stories and audio files ensures that highly diverse student demographics are actively included in the learning narrative. However, deploying these multimedia outputs outside the classroom introduces strict ethical constraints. There is a concrete warning regarding academic publishers and the submission of AI-generated visuals that every educator must understand. Major publishers, including Taylor & Francis, strictly prohibit the inclusion of any AI-generated images in submitted research. Faculty must strictly separate internal classroom lecture enhancements from their external, formal manuscript submissions. When bound by closed-loop frameworks and strict ethical adherence, generative AI becomes a high-precision tool to enhance classroom engagement and streamline